plan for today, to review these rules and then start to look at sine and circular measure. So last time we looked at the cosine rule, and remember we use it if we don't know the ratio. It's to do with this triangle. So we have a particular convention we use when drawing out the triangle, and here's the formula in its two forms. And last time we were practicing using it. The good thing about using the cosine formula is there's no real rearrangement involved with it. You either use the formula in this form to find the side, or you use it in this form to find an angle, and that's the two ways you use it. You won't use it any other way. So you just got to look the formula up, or eventually if you used it enough you'd remember it. The sine rule looks more straightforward, but you do have to rearrange those ratios a bit to find the missing what you're after. So some people find the cosine rule a bit easier to use because of that. So there's no rearrangement involved. Let's look at a couple of examples. I don't want to run through the whole thing. I just want to start them off. I want to decide which rule we're going to use and in which form, and then leave you to finish the questions. So if I've got a problem like this to do, the first thing I would do is to draw it out. So I draw my triangle using the convention. It doesn't really matter whether or not the triangle looks like the problem you want to solve, because you don't know necessarily what it's going to look like. But I just draw some sort of triangle. I'm not given any letters, so I don't know any of the symbols, so I can just make my own up. Let's call it A, B, C. So if I call those angles A, B, C, I've just got to make sure I follow the correct convention for the sides. Side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So I write down my convention. Right, a laboratory 9 meters wide has a span roof that slopes at 36 degrees on one side and 44 on the other. So I can put, this is 9 meters, because that's the width of the roof. I know that the angle on one side is 36, so let's call that one 36 degrees, and on the other side 44 degrees. So put the information on that you're given so you can see it. If you can see it, that helps you to decide which rule I'm going to use, the sine rule or the cosine rule. Remember the criteria for using the sine rule. What is that? Need to know a ratio. Yeah. Do we know a ratio? We can do, because yeah, good. So first off, because the angles of the triangle add up to 180, I can find this. So find B using angles in the triangle add up to 180, and then we do know a ratio. We know side B to angle B, so therefore we can use the sine rule to find A and C. The sine rule: A over sine A equals B over sine B. We write down the ratio that includes what we want to find, in this case side A, and the ratio we know, which is B and angle B. So that's what I'd write down. I'm after side A, so I want to get little a, side A on its own. So what do I do with the sine A that's underneath? Times it, okay, to get rid of it. So that means that side A equals B over sine B times sine A. And then I put the numbers in. I know B, I know sine, I can find the angle of sine B. So sine of angle B and sine of angle A, and work it out. Yeah. And then the problem would be, the procedure would be pretty well the same to find the other side, side C. So another example. In this case, there's a lot of information. It's quite wordy. So drawing it out will really help. I would recommend that you certainly draw this one out so that you can make sense of it. PQ and QR are the phasors representing the alternating currents in two branches of a circuit. Phasor PQ is 20 amps and is horizontal. So I know that I could draw a line now, PQ, a horizontal line, call it PQ, and that would be 20 long. So this would be, say, P, this will be Q, and that will be 20 amps in this case. Phasor QR, which is joined to the end of PQ to form a triangle, is 14 amps. So phasor QR, so it's going to start at Q and go to R. So let's just do this. It doesn't, I'm not exactly sure what the angle is yet, but, oh, well, yes, I do. It's 34 degrees, 35 degrees. So that's what I draw it, and that's going to form a triangle. So here's our triangle, PQR, and we're given that that's 20 amps. It's 14 amps long, so that's 14 amps. And it's at an angle of 35 degrees to the horizontal, so I know that angle is 35 degrees. Determine the resultant phasor PR and the angle it makes with PQ. So I'm after this and the angle it makes with phasor PQ. So I'm after this. So I would use some symbols to put on what I'm after. I'm after X side PR and I'm after angle theta or angle P. So having drawn it out, now we can try solving it. Can we use the sine rule? No, we can't find angles R and P, so like in the last one, we can't identify the missing angle. We don't know a ratio, so we have to use the cosine rule. So what we say is, we can write down what the cosine rule is. A squared equals B squared plus C squared minus 2BC cos A is the cosine rule. So you can write that down. We've not got a side A, a side B, a side C, and an angle A, so that doesn't correspond to this, but that's not important. It always works. This is how we use the cosine rule. To be able to use the cosine rule, it's set up in this way to find a side. Whoops, to find a side. So in other words, that is going to be our x. And to find x, we need to know the other two sides, which we do, 20 amps and 14. So it doesn't matter which we call B and which we call C. We don't even have to write down B and C. It's going to be the other two sides squared and then added together, minus 2 times the other two sides times the cosine, and the angle here is always the angle opposite the one we're after. So this is angle A here. This is angle A because it's opposite the side we're after. So given that information, we can just say therefore x squared equals 20 squared plus 14 squared minus 2 times 20 times 14 times the cosine of 35 degrees. And then all we've got to do is put that into the calculator, and there's the answer. Or not quite, is it? Because what does that tell us? It tells us the side squared. So at the end we have to square root. Don't forget to square root at the end. So now we can plug the numbers in and find a value for x. And I'll leave you to finish that. Once you've got x, then we know a ratio, so we can use the sine rule to find theta. Or we could decide, actually, let's use the cosine rule because that's in the other form. So we can either use the sine rule or the cosine rule in this form here to find the angle, theta.